All right, in this video, you will learn about percent composition. Okay, percent composition is a convenient method for expressing the composition by the percentage of each element out of the compound, right, or the whole sample. And so it's just like a regular percent, it's a part out of the whole. And so the percent of one element, right, is the mass of the element divided by the mass of the whole sample, right? And then times 100. So let's try this with water. Okay, so we see here the percent composition of water, and this is by mass. So even though the formula, right, is H2O with two H's, remember that hydrogen is the first element, and it's small, right? It only has one proton. So the mass of it is much smaller than the mass of oxygen, right, which is close to 16. Okay, so about 1 for hydrogen and about 16 for oxygen. So when you look at the percentage of mass for each element in water, it's 11% hydrogen and 89% oxygen. All right, so let's try to work this out using our equation. So if we're looking for the percent of hydrogen, since there's two of them, I'm going to add 2 hydrogens, or you can multiply by 2, 1.0079, divided by the whole. And the whole is for 2 hydrogens and 1 oxygen. So if oxygen is 16, each hydrogen is about 1, so that's about 18. But if you add it up precisely, it is 18.0148. And these are expressed in grams, right, or AMU, grams per mole or AMU, and they cancel out anyways, all right, times 100. And that comes out to 11.189%. Okay, doing the same for oxygen, the percent oxygen. This is 15.999 grams per mole over 18.0148. I guess I should write grams per mole. You'll learn about moles in a future video. Times 100, these cancel out, and that gives us 88.810%. Okay, so about 11% here for the hydrogen and about 89% by mass for the oxygen. Okay, so what this means is that percentage, right, based upon the mass of each element in the compound, it doesn't change, right, for that substance. So if I had 10 grams of water, that 10 grams, let me just write it here, if I had 10 grams of water, that would be per element, right? Hydrogen would be about 1.1 grams, right, for the mass of the hydrogen, and 8.9 grams for the mass of the oxygen. Sometimes you don't know, right, the formula, but you can still do a percent composition if you know the mass of each element, right, and the mass of the whole sample. All right, so here's a problem. It says a 3.67 gram sample of the mineral chalcopyrite was determined to contain 1.27 grams of copper, 1.12 grams of iron, and 1.28 grams of sulfur. What is the percent of each element in this compound? Okay, let's do one of these. All right, let's look at the percent of copper. Okay, so following our formula, it's the part out of the whole, so 1.27 grams of copper divided by the whole sample, 3.67 grams for the sample, times 100. And that is 34.6%. You'll do that for the other elements, and if the mineral chalcopyrite is only made up of those 3 elements, they should add up to 100. Okay, so like I just said, this mineral is only composed of these 3 elements. Let's see. I don't know how it is listed, but it looks like there should be 1 copper, 1 iron, and 2 sulfurs in this. Okay, but those are their percent compositions. So you can check your answers if you do the calculation for sulfur and iron, and that should add up, all 3 of those should add up to 100%. Oh, there's a formula there. Okay, so here's the formula for chalcopyrite: 1 copper, 1 iron, and 2 sulfurs. And that's a repeating unit for this mineral. So here's a question: would this mass percent differ for a different sample of this mineral? Okay, so let's say we didn't have the 3.67 gram sample, we had a larger sample or a smaller sample. Would the percent by mass be different? Okay. The answer is no, because this is the mass percent that's found in this compound, and this compound is not changing. So it doesn't matter if you have a lot or a little, these percentages will be the same. So if you had a 100 gram sample, what mass of copper would it contain? Okay, so if we had 100 grams, and since it's the same mineral, chalcopyrite, it should contain 34.6% copper. And therefore, that would be, let's just write it out. We have 100 grams times the percent, which is 0.346%, and that would give you 34.6 grams, right, of copper. Okay, so that percentage remains the same regardless of your sample size. Okay, let's do one more practice problem. A 4.55 gram sample of limestone, which is calcium carbonate, which is chalk, contains 1.82 grams of calcium. What is the percent calcium in limestone? Oh, and here's a nice picture of the White Cliffs of Dover, right, in England, largely made up of limestone, calcium carbonate. Okay, let's do the problem. It's asking for the percent of calcium. Okay, percent calcium. What's the mass of the calcium? 1.82 grams. What's the mass of our sample? 4.55 grams times 100. Grams cancel. And that turns out to be, actually I didn't calculate this yet, 40%. Okay, so 40.0%, right, calcium.